Hello everyone, this is Ms. Saturian here, and today's slideshow will be talking a little bit about writing in science and how you can use claim evidence and reasoning to do this. The essential question for today is, how do scientists structure their explanations and arguments based on experimental data? This is a big piece of communicating scientific results to others, and this slideshow will help you have an organized way of communicating explanations and arguments that you may have based on experimental data that you may discover. The standard that we will be covering in this slideshow will be SE1C. After this slideshow, you will have important information to be able to make a prediction or claim supported by evidence from a data table or a graph and be able to explain your reasoning.
So the first thing that needs to be done in order to make a claim is to start off with a question or observation that you've made. It allows us to start with something that we are curious about that we want to explore. It could be like, what is the universe made of? What is consciousness? How does a single cell become a whole organism? Are we alone in the universe? How and where did life arise on Earth? Or how hot will the greenhouse world actually be? It can also be some type of observation that you have made that leads to a question that you want to answer. This is the same first step of the scientific inquiry process, or the scientific method.
The first step is to design an experiment to find a possible solution to that question that you have and to collect data from this experiment. In any type of experiment, make sure that the data set that you collect from your experiment is unbiased and significant. This means that you have gotten the data in a fair manner, not trying to make your data show one specific thing or another. Simply put, you're collecting data regardless of what the outcome of that data shows. You're simply just collecting data. When we say significant, make sure that the data is related and relevant in order to answer your initial question that you had. Just like we have done in our first unit, create graphs and perform calculations using the data until you feel like you have enough information to answer your question. If you see that your data is not enough to do this, you probably need to go back and rethink the design of your experiment and the data that you want to collect. You probably need to make necessary changes, collect some more data until that data that you're collecting is helpful enough to help you answer your initial question. After you have collected enough data, you can use the claim evidence reasoning protocol to explain your answer. In short, the way this works is you look at your data and make a claim. You then back it up with evidence and reasoning to help you explain a possible answer to your question that you had. When making a claim, you use one sentence to clearly state the conclusion you have come to based on your data. The claim should directly answer the question that was asked. The following are some good sentence frames to help you make a claim. Let's use our texting and driving experiment we conducted to make a claim about the question, is texting and driving dangerous? So here's an example. After analyzing the data I collected from the texting and driving experiment, I conclude that being distracted while texting and driving is incredibly dangerous. Or here's another one. It is clear that texting and driving is incredibly dangerous. Or let's do one more. In this lab that we investigated whether or not texting and driving would be a dangerous thing to do. From my results, I'm able to infer that it is indeed incredibly dangerous to text and drive. The next step after making a claim is actually providing evidence from your data to back up that claim. So provide specific evidence from graphs, drawings, data tables, or text that support your claim. Remember, there may be more than one piece of evidence, so this would be a really good place to identify the relationship between two different variables that you were measuring. Again, here are some good sentence frames that could be used to help you back up your claim with the necessary evidence. I would suggest adding these into your notes for all of these so that you can quickly reference them when you are trying to make a claim, provide evidence, and back it up with reasoning. The last step in this protocol is providing reasoning, which really means connecting your evidence to your claim. Give as much detail to justify how or why the evidence leads to this conclusion. The helpful thing here is that you're already doing all three types of these in your everyday life when you want to provide any type of point. Let's say you're having a conversation with someone. You may make a claim about something like sleeping earlier makes you feel more energized the next day. You argue this point by providing evidence based on data that you've collected on nights that you sleep well and your energy levels the next day. You then use reasoning to connect this evidence to the claim you make. When these three things are done, which are making a claim, using evidence, and reasoning to justify how your evidence leads to your conclusion, what you're saying has more worth because you have things that are backing it up. Here are some more sentence frames for reasoning. Again, I think this would be a good thing to put in your notes to be able to refer to later. So here's a quick example. We start with our question. Do bigger oranges have more segments in them? Here's your data that you collected from an experiment you conducted. So here's a couple of different oranges, 3 to be exact, with different masses. And the segments that each of them had were 16, 17, 16. Pretty similar. Here's your claim. No matter what their mass is, all oranges have roughly the same number of segments. Here's your evidence. When I counted the number of segments in oranges with a variety of different masses, I found that there was no relationship between segments and mass. The graph of this data would be a horizontal line. Here's a good place where you can compare the different variables and the relationship they have. Here's the last piece, reasoning. Because increasing the size of the orange does not increase the number of segments, I would expect all oranges to have roughly the same number of segments. So let's summarize by revisiting the essential question. This is something you could use to answer in the summary section of your Cornell notes. It's how do scientists structure their explanations and arguments based on experimental data? Thanks for listening.